Bhumaji, are we ready? Or
Is
No,
someone
no, sir, wait for 5 minutes.
yeah, wait for
I'm
5
going
minutes. That's
live.
what I thought. Yeah.
who's joining? Who's left? Is
Nobody
everyone-
has left from what I can see. Only
Well-
Dr. Dhaka is going to join. Mr. Sampath, how do I introduce you? Do I use your CII affiliation or something else? He's
Yeah,
muted.
CII, sir. CII, sir.
CII. Okay. Okay.
Yes, sir.
Kirti, sir, we can start.
Thank you, Dr. Thank you, everyone. Thank you, the panelists, friends and colleagues. It's my privilege to welcome you to the 111th episode of INHAF's webinar series on Rethinking City. Today's webinar is on energy efficient buildings, a very important subject. And it is the 7th theme of the 10-part sub-series we have been running as part of INHAF's work in Chennai on climate change. I do want to mention this for a good reason. The 6 episodes we ran up till now included a discussion on COP28 and urbanization. And we also discussed cities and climate change, because we're looking at Chennai in the context of urbanization and cities. We're looking at climate change through the lens of a city. And then, of course, we started looking at specific themes like urban flooding, extreme rainfall, urban heat and its effect. In island effect, we started looking at urban transportation, and we have looked at solid waste and sewage. So we have already covered the 6 themes on the sub-theme of climate change project. And we are coming up with the 7th module after a break of more than 2 months, probably, as we thought that we needed to prepare ourselves better to improve our reach and enrich our message to the city, its concerned citizens, and the climate change stakeholders in Chennai. We hope to offer one webinar every week for 10 days for the next 2 months or so in order to complete our 10 event webinar series. Before Dr. Raghunandan, who is moderating this 10-part series and is also the project lead on climate change, handles today's topic with his competent team of panelists. Let me briefly tell you what is this project in Chennai doing and why have we been running this webinar series on rethinking cities for close to 3 years, and under which over 500 urban experts, professionals, and practitioners from across the world have participated and covered more than 50 themes and sub-themes on urbanization and city development. Let me first come to very briefly on the webinar series. Over the years, while introducing this webinar series on rethinking city, as to why we are doing it and what we want to achieve, I have emphasized four-part narrative. First, that we as people, government, and professionals have not understood the enormity and complexity of India's urban challenge. And that reflects in the response pattern and gives us the quality of cities we have now, small and big, old and new. And also on issues such as infrastructure and governance, water and environment, housing and climate change. Though the cities are known to be the engines of growth, they are saddled with multiple and multidimensional challenges. And our first major task in channeling the urbanization process, managing growth and planning development of our cities is to find new direction, a better working solution. So looking for new solutions and better working directions is something that we're looking for as the first objective. The second matter we have emphasized over the period is that the government is at work with policies, programs, plans, and investments, and regulatory framework. But this work needs much more than what is on offer. The third point of the narrative is that there are many resources outside the government system, in the private sector, and even in the non-profit sector too, if we look for them, which could be tapped to address the urban challenge better. And our fourth point is on a need for a societal partnership to meet the urban challenge better. We believe that those who combine resources working in tandem will give us a better measure of the challenge and equip us for a better response. This webinar series is an effort and it's seen as a contribution to forging that much needed societal partnership. So entire effort for the last 3 years is directed on one major objective: try and build societal partnership. Now that said, let me say a word about INHAF's climate change project in Chennai. Dr. Raghunandan would emphasize and elaborate further, but let me kind of give you why we are doing it, what is the main objective. This is a 6-part project and being done by a small but dedicated team of people and is meant to do the following 6 things. 1 is to understand how will Chennai as a coastal city be impacted by the climate change over the years. 2nd is to learn how is the city preparing to cope with the challenge. Who is doing what? From the government to academic community to civil society to media to business to industry to common citizen. The 3rd objective is sharing that information and knowledge across stakeholders with a view to create a common platform, as tendency is to work in closed, isolated, and unconnected silos. The 4th objective is helping vulnerable communities to understand the threats better. How are they going to be impacted? What plans are being made by the authorities to protect and help them meet those challenges better? And how could they participate meaningfully in making those plans effective and solutions better outcomes yielding? 5th objective is a more ambitious part of the project is to contribute to, participate in, and demonstrate to the extent possible in cities' efforts to decarbonize or reduce carbon footprint over a period of time, and mitigation and adaptation strategies. And the last objective is our most ambitious task is to find ways and create possibilities for better participation of the city community in meeting the climate challenge more effectively. We are working to take the climate challenge to people and make them partners, bhagidar, contributors in addressing it. We're convinced that this one challenge and one task where global is local. We also believe that with a strategy and emphasis on informing and engaging the populace, the citizen, the community, we will find better solutions and more effective answers. This webinar series that Dr. Raghunandan is moderating is part of the process to inform and engage people. In this matter, in meeting the climate challenge, everyone and everything has a role, from the global wisdom to world scientists to corporate money to advanced technology. No less important is the role of the common citizens, the last frontier, the one who will suffer the consequences in his or her home of the acts of others across the globe over centuries. Our project has the message that we are all together in it, and that seeking solutions, contribution of everyone counts. The climate change response needs to be both top-down and bottom-up. And in doing this, in making this, we are seeking your contribution, your engagement, your help, and your solutions. With this rather long, elaborate introduction, I hand this over to Dr. Raghunandan to conduct the session today. Thank you, Dr. Raghunandan.
Thank you, Kirti. It gives me great pleasure to welcome all our speakers to this panel. And I will be shortly making a brief presentation on framing some issues for the discussion that we have to follow. I've posed some issues and some questions which the other speakers may like to address or not as they see fit. But these were issues which to me struck me as being major issues which we need to consider while looking at this problem of energy efficient buildings. If I can ask my colleague Chitrakshi to share my presentation, that would be nice. Yeah, so here we are. This is my presentation. Next, please. Yeah, so a very quick background, not necessarily for our speakers, but for participants and viewers who have joined us, who may not be that familiar with the subject as our experts on the panel are. Emissions from buildings, which includes energy used by appliances inside the building, your ACs and refrigerators and TVs and whatnot, are a major, but really speaking, a neglected sector in India's emission reduction plans. It did not figure in our earlier efforts through the Planning Commission's Low Carbon Committee. I've just masked that with an asterisk because in the interests of sharing all information, I was a member of that committee. But nor was it part of our commitments in our NDC, or nationally determined contributions at the Paris summit, nor in the updated NDC at Glasgow at COP26. However, the recently concluded COP28 in Dubai, based on the global stocktake of where we stand with regard to efforts to combat climate change, and which showed that there's a huge gap between where we ought to be and where we are, a gap of about 14 gigatons of carbon dioxide equivalent. the COP decided that next generation NDCs now need to be tabled before COP 30 that's in the end of 2025, and that these next generation NDCs should contain economy-wide emission targets. I'll stress that because our NDCs at present essentially have targeted three sectors. One is renewable energy, electricity production through renewables. Within that, a target for solar and other renewables. And third, a target for carbon sequestration by tree cover. These are the three targets. So we don't have an NDC which covers transport, buildings, waste, etc. So many sectors are not covered here. But since we are required to now submit economy-wide emission targets, it's very likely that we are going to submit an expanded list of emission reduction targets next. And I can't see that we will be able to do that without taking the building sector on board, because buildings is a major part of the emissions profile of the country, which is currently about 25% of total emissions. And this is in a context where roughly between 50 to 70% of building stock by 2050 is yet to be built. So we've got more than double of the building stock today is still to come up. And we are already 25% of the total emissions in the building sector. And I've given some figures here of emissions from buildings, which are largely drawn from C-STEP's study and their modeling, which essentially says that almost the entire carbon budget, that is the amount of carbon India has between now and 2050, the space in the atmosphere, will be used by the building sector alone. Or since it will not be, that means we'll exceed our carbon budget by a lot. And that's clearly not going to be allowed and will not be countenanced by the international community. So when we talk about the building sector, I just want to emphasize that the building sector emissions consist of two parts. One are what are called embodied emissions. That is, emissions contained in materials that go into buildings, into cement, concrete, etc. And emissions which have gone into the construction industry, the transport of these materials, the removal of waste and the handling of waste and so on. These are called embodied emissions. And then the operational emissions, that is the emissions which come from use of the building and the appliances within it. It's estimated broadly that the building envelope itself, the skeleton, if you like, of the building, the way it's designed, the materials it's made from, can save about 30% of energy consumed inside the building. And energy efficient appliances can also contribute equal, if not more, of energy savings, and we can come to that. So buildings and the construction industry can put together save about 70% of this carbon budget that I was remaining that I was talk of, which is still not net zero, but it is quite a lot. Next, please. How is India planning to tackle this so far? For long, we have felt, I think policymakers in the country have felt that buildings and construction sector is a major growth engine of the economy. And therefore, let's be careful, let's not touch it. This argument was made for the automobile sector also. A lot of policies which people were demanding was resisted by the automobile sector, and the government went along saying, this is a major economic activity. Let's go easy on tackling that. Otherwise, the economy may suffer. So currently, the green building regulations cover only a small section of large offices and commercial buildings under what's called the ECBC. The Eco Nivas Samhita, which is for residential buildings, are framed, available, but although on paper they are supposed to be mandatory according to the modified act, they have not been implemented across the nation. However, There is movement on the policy front, and India may soon see mandatory ECBC and Econivas Samhita, which may also cover the embedded emissions. But of course, much will depend on implementation, on enforcement, on capacity building of the industry, and on incentivization for all the stakeholders, for users, for builders, for architects, for the construction industry, and so on. Next, please. Chitrakshi, yeah. So just a few questions I'll leave you with. Should energy efficient buildings also be included in India's next submission in our nationally determined contributions as part of our contributions? Should ECBC and ENS be made mandatory? And if not, how do we go about implementing it and achieving the results that we want? What kind of policies, what kind of incentives can bring us the desired goals if we do not have mandates? Third, which is a technical question for those among the experts who want to look at this, are there any changes that you would like to see in the ECBC codes or in the Econivas Samhita codes? My next poser is perhaps a little more complex, but we have industry representatives here among us who could perhaps address this issue. Is the industry ready for this shift if this does come about? Where do we stand with regard to that? And should this effort also involve the appliance manufacturers? Since we are talking about reducing the emissions from appliances, air conditioners, refrigerators, televisions, fans, etc., inside the building, should they not be part of this effort? And last two questions is pertaining to Chennai specifically. Is Chennai ready to implement the ECBC or Econivas Samhita, given the fact that the Chennai Climate Action Plan has rather ambitious targets of addressing 40% of buildings, both retrofitted and new, by 2030, leading up to 60% in 2040 and going up to 100% later? And what would you like to see? That is the speakers and our experts here. What would you like to see in terms of an implementation strategy? Making a policy is one thing, but a strategy to ensure that it gets implemented smoothly is another. And I would love to hear your thoughts on that. So these are some issues which I have posed to our guests. Dr. Shivraj Dhaka of CII and the Buildings Council here in Chennai is traveling, and he has requested that he be come in early and be allowed to leave. So I will first request Dr. Dhaka to speak. What I'm going to do is we'll have about 15 minutes presentation by each of our panelists. That will give us about an hour or so, and leave about 15 minutes, 30 minutes for Q&A, discussions, etc. So I will switch off my video, but you will see my video coming on when you're about 13 to 14 minutes into your presentation, which is a reminder to you to kindly, in the next couple of minutes, bring your presentation to a close. I hope that's all right. And with that, I'd like to invite Dr. Shivraj Dhaka to come in. Chitrakshi and Dr. Bhuma, can you see that he joins us?
Yes, sir. We will contact him.
Okay. He's obviously going to join us using his mobile, or?
Yes, I think he's traveling.
Yeah.
Please give us 2 minutes.
Yeah. I think he's there. I see him.
Yes, he's joined
Hello,
using
sir.
raw link, I think.
Good evening, everyone.
Good evening. Good evening. Our Dr. Shivraj Dhaka has just joined us, so I'll ask him to make his presentation in maybe 15 plus minutes. Dr. Dhaka is part of CII and he's part of the Green Buildings Council in Chennai. And I would like to request him to make his presentation. Dr. Dhaka, please.
So, sir, thank you very much for offering this opportunity to CII IGBC for this particular presentation on net zero energy buildings. I hope you are able to hear me.
Yes, yes, we are. Please go ahead.
Sir, but I will share my screen so that I can also utilize some animation which are put there.
Okay, then you can share it yourself.
Yeah, just a moment.
Chitrachi, you can take down what you have uploaded and then he can do it himself so that he can.
Yeah, I think my screen is visible to all of you.
Yes.
Okay, let me also put on full screen mode. Okay, just a second. Okay. So this presentation is primarily about net zero energy buildings and built environment. And I got message from the Raghunandan sir, like I should cover several part of net zero energy, which can make sense for Tamil Nadu or Chennai with regard to climate mitigation. So I have tried to cover several points, but I don't think like one can make justice to make presentation in 10 minutes and also to cover like every part of energy efficiency in buildings. But let me run the presentation. If you find any difficulty, clarification, definitely we can have a Q&A session. So the building which you see it here, it was the first green building in the country, and this is the headquarter of IGBC. You know, when we started in 2001, this building converted into green while considering several measures. But in 2017-18, we realized like there are many technologies available in the country. There are many more advancement which can be put into practice than this building, which is like first green building converted into the net zero energy building after having lot many retrofitting in completely air conditioned system, whatever the building it had in 2001. And also earlier you can see like the photovoltaic was not completely covered with the atop, but later on bifacial solar photovoltaic has been installed. You know, a bifacial will generate little more energy compared to conventional solar photovoltaic system, as well as it will cover little less space than a conventional system. So there are many advantages over bifacial. So this is the journey we have witnessed from green building to net zero energy building, and this presentation will showcase like how it can become a story for every building, not only like our office, but it can become a true message for every buildings with regard to green building to net zero. So when we define the net zero energy building, we also defined how demand can be reduced. Even Dr. Raghunandan mentioned like, okay, it could have some impact in Chennai or Tamil Nadu. So we cut down energy demand. Of course, it will have huge impact on the source energy. This means like whatever the energy we get from either solar or maybe power plants, it could have good replica on a downstream with regard to like how energy demand can be cut down. Then highest energy efficiency would have focus for every building during design as well as in operation. And after defining energy efficiency in every building, whatever the left out, this energy should come from the renewable energy. So this is the definition IGBC has defined. But if you see a Bureau of Energy Efficiency, which is nodal agency for improving energy efficiency all across the country, for building sector as well as the sector which are there in industry also. Let me also off it just a second. So Bureau of Energy Efficiency mentioned like any building which is just relies on like renewable source, but it is only able to meet out or offset some part of it. It can become a net zero energy. But some buildings, those are surpass the total energy required for a given building and produce much more than the requirement. These buildings can also become net zero energy positive building. But if you see with regard to IGBC and Bureau of Energy Efficiency, we also give huge importance on energy efficiency and the renewable. But if you see Bureau of Energy Efficiency, they have defined like what building can be called a net zero, like Sunya label is like net zero building, and their energy performance index. Energy performance index is very simple. We should have total energy consumption for a given building and divide with the total built up area we have for our home or maybe like commercial building also. This should be less than 10 for commercial building, and for residential building it could be little less than 10. With regard to Shunya level plus or the net positive energy buildings, this EPI would be lesser than zero. This means whatever the renewable energy we generate, it will completely offset the energy demand, but it would also generate little more than our requirement. You can also find lot many other definitions. This is just listed from the United Nations, but UN doesn't talk about net zero energy. They talk about the total carbon offsetting by any source of energy users. So this presentation would be shared with the team so they can circulate with all the stakeholders. So this net zero energy was launched in 2018, and today we have many projects all across the country. I will also showcase some case studies during my presentation. So when we define net zero energy, our thought process was this should also address several policies which are there in the country. So primarily when we talk about net zero energy, we are also talking about energy efficiency and renewable. So energy efficiency is well defined under the Energy Conservation Act 2001. Later on, ECBC, like Energy Conservation Building Code, which is just shown here, it was developed in 2007. 17 was the first revision. I'm happy to mention that right now, ECBC has been further updated and it has been called now Energy Conservation and Sustainability Building Code, which is like ECSBC. And ECSBC will not only address the energy part, it will also address water, building materials, indoor environment quality, commissioning of equipment, how sustainability can be achieved through site selection or planning. So all these parts which are there in the green building, which which will also be part of the ECSBC, which would be revised very soon by Government of India. The second part is it address climate policies which are there on energy efficiency as well as the renewable energy. So while adopting net zero energy, we are really confident about having huge huge benefits with regard to energy savings and having more and more penetration of renewable sources in every building typology. So let me run through one very unique strategy about achieving net zero energy. You will find while having net zero energy, it is extremely important for every new building designed to address passive elements. While talking about passive, it can't be like one or two measures. There are plenty of measures which can be put into practice, which can be integrated with the design. So some of the examples could be change in orientation. I have one slide which can showcase example of change in orientation into the energy consumption. Then building envelope, which is a combination of wall, roof, assemblies, and fenestration, which is like glass. Every element will also have lot many passive opportunities. It can be integrated. They would be with the building throughout the lifespan, and it can save huge amount of energy. It can cut down at least 10% of the energy reduction, which happens to every building without having passive measures into the building. When we talk about active measures, there would be many more measures. And these active measures we have defined into energy efficiency and renewable. Energy efficiency will address air conditioning, lighting, auxiliaries, and the appliances. As you are aware, there are more than 20 appliances today from Bureau of Energy Efficiency, which are star labeled. We don't need to see every detail of them. We just see the star. More the number of star, there would be more efficiency of the product or any of the appliance which we procure from vendors. So renewable energy, it can be either on-site, it can be off-site, but the main objective of having renewable is how we can offset 70%, 80%, 90%, and to offset 100%, we can achieve the net zero mission or net zero certification, or even if certifications are not applied, no worries, but project can demonstrate how net zero energy can make sense for them. I have put couple of things. This is also a passive strategy, like there are light pipes which are installed into the project, and these light pipes, they reduce the use of artificial light in corridors. Then there are some passive elements, although it would be difficult to use them in Chennai, but yes, they can also utilize good efficiency into the project. So when we have a net zero energy certification, we consider several parts, and passive is by default integrated for new buildings, but primarily when we see the building growth, even Dr. Raghunandan mentioned like what could be the strategy for 2050. So today we have lesser new buildings and many more existing buildings. So there could be huge retrofitting opportunities for these buildings to become and demonstrate net zero energy. So we give more than 75% of weightage to energy efficiency alone, because energy efficiency pays back from day one. And then also try to fit like which retrofitting options can be better for the project. I have showcased something here. Like many a time, all buildings, they do have centrifugal fans. And today, most of the project or most of the air distribution system wouldn't have a centrifugal fan. Either they have the EC fan, or more than EC, they would also have zero energy fan or axial fan, which doesn't have any energy losses there. You can also find like how they will have the smooth airflow. This is one example of like centrifugal airflow. And these are like pumping solutions which are really efficient. And there are a couple of companies, they are based in Chennai. Those are offering this kind of solutions. So this is how we segregate them. Let me tell you like how energy efficiency happens, which is having highest weightage in net zero energy. Some of the buildings, those we have rated, they were like having very high energy performance index in 2010. They did gradual improvements. Slowly they had many retrofitting, and today their energy performance index is like less than double digits. I'm sorry, like less than a triple digit, which is like 90 kilowatt or lesser than this. Another message we would like to give you is like when we have renewable sources, it is not only like 25% weightage of renewable, but it is the overall weightage of 100-point scale into renewable energy for 25%. But it must have 100% of the requirement for a project to offset the grid energy used by renewable. It can be on-site, having net metering policies. Tamil Nadu is like good state with regard to solar policies. And second thing, if energy demand is so huge, cannot be computed by on-site, it can also have off-site by having wheeling also. This is ECBC, which defines compliance route, like building envelope, comfort systems, lighting, and electrical and renewable system. These are having some compliant route with regard to mandatory conditions, as well as if mandatory conditions are met and project is having more energy efficiency, they can also demonstrate through energy performance index, which I will discuss in coming slides. Some projects, those are really interested to cross some milestone which are beyond ECBC also. They can also refer SN 90.1. Some of the latest versions are like 2022 or so, which defines really ambitious goals for energy efficiency. So when we talk about energy efficiency, of course, they are part of like roof, wall, glass, and then air conditioning, lighting. But the key thing is when we have more existing building, there would be more energy efficiency, implemental opportunities through retrofitting, and also to add capacity of renewable sources there. When we compare new buildings, obviously there would be more design interventions there, and these buildings also showcase how they are better compared to new building age which are not meeting the code compliance there. So these are the envelope assembly values with regard to overall heat transfer coefficient. These values are defined there, but Chennai comes under warm and humid climate. So it is suggested to use some of the walling assemblies, some of the material which can reduce the overall heat transfer coefficient, or we can understand in a very simple language like we should provide wall which has optimum level of insulation, and these insulation can be created by many different options. Sometimes you don't need to use insulation, it can be a air cavity. Sometimes air cavity can be combined with some different type of insulation metal which are well aware in every climatic zone or cities. This is air conditioning. Air conditioning plays very important role because in every commercial building, in every residential building as well, they consume most of the energy. It is said most of the time they consume more than 50 to 55% of energy in every commercial building. And in recent trend, it is really high in residential building also. But these are the performance levels defined for air conditioning efficiencies in commercial building. So we have three approaches. One approach is called ECBC, which is mandatory for every building type. And while going for ECBC, either you follow the COP or you follow the IPLV. IPLV stands for Integrated Part Load Values. So most of the time when we design for worst conditions, but worst doesn't come every time. So we should design buildings for part load efficiencies also so that we get more benefit from the cooling savings. Another part is lighting. Lighting is important because every space need either the artificial or the daylight or combination of both. So we recommend to have lighting power density, which is defined for different building typologies in ECBC. It can be referred, available online for everyone to refer it. These are the appliances I just mentioned. There are more than 21 appliances available from Bureau of Energy Efficiency. They have rated for every OEM in the market. But the main advantage of using appliances with star label is every after 2 years, these labels are modified, these labels are upgraded so that whatever you had purchased, which was 5 star about 2 years back, wouldn't qualify for 5 star now. It would become either 2 star, 3 star, or may not qualify the criteria which has been developed by Bureau of Energy Efficiency. So let us understand how to calculate EPI to demonstrate whether my building would meet ECBC or not. So let us assume we have some energy consumption which is evaluated for a design case, and this is the actual energy consumption for the building. So we have a built-up area which is like 2000 square meters. If we divide the total energy consumption, which is like 130,000, divided by 2000 square meter, you get the design EPI of 65. Then actual consumption is like 100,000. You again divide by the 2000, which is built up area, you get the EPI of 50. When you calculate EPI ratio, which is like actual versus design, you get 0.76. This means like 50 divided by 65. You get the EPI ratio lesser than 1. This means your building qualifies for ECBC. Let us discuss some more example when it doesn't qualify. So let us see. You have again put a building which annual energy consumption could have 160,000. Yeah, 160,100. And the standard case, which referring the ECBC case, would have 150,100 consumption. If you divide the built-up area, which is like 100 square meters, okay, you get the EPI. And if you divide the actual versus the design, which is like 160 by 150, your EPI ratio comes 1.06. This means this kind of building will not qualify, which has more energy consumption in the standard, and in actual or proposed case, they will have little more. So this building can't meet the ECBC compliance. Here is the case, which is little reverse to the case which we have discussed now. It has more energy performance index in the standard case, which is like ECBC case, than the actual case, which we will have now. So 150 divided by 120 divided by 150, your building is having EPI lesser than 1. This means this kind of building can meet the ECBC compliance. Now let us talk about on-site, off-site energies. I think I had to run little fast because I'm taking more time. So on-site, this is one example which can have net metering and the gross metering based on the policies which state has. But I don't think like Tamil Nadu has any problems. It is very good with regard to policies for net zero or like renewable implementations. This is offsite. Project can put plant outside their premise. They can have wheeling through the discom or any of the renewable energy companies and can wheel the power, which is like green power, to offset the grid energy consumption. So we have three threshold defined for net zero energy. One is for any building which is having 75% of the energy requirement are met through on-site and off-site renewable energy. This building would be called net zero, sorry, near net zero building. Any building which is offsetting 100% called be net zero energy, and net zero platinum means it offset little more than the actual requirement in an annual basis. On an annual basis. This is the case
Doctor,
of our building.
Dr. Dhaka, could you please try and wind up in the next 3-4 minutes?
Absolutely, sir.
Thank
So
you.
this is case of like our office. You can see like all the cooling system we have retrofitted with the new ones, which are very efficient. But efficiency for us, it's not really important when we consider 100% load, because our office is never being operated for 100% load. It mostly happens for like 50-60% load or little lesser than that. So we selected items which are best at part load. This is the story of lighting. We retrofitted in 2017-18. You can see n number of lights, more than like 211 fixtures. But when we retrofitted, we hardly had 86 fixtures, and their efficacy is very high. Efficacy is like lumens per watt. Earlier it was 60, and now it is like 132. So this reduces the number of fixtures. Let me also remind you one more thing. Whenever we procure lights shall be tested for like LM79 and LM80, which gives guarantee for the life of the LED source, which means like it will burn for like more than 45,000 to 50,000 burning hours, and also the quality of the light. It should not happen like it will have blur, or it will not last more than like 1 year, 2 year or so. This is how we did retrofitting. The temperature of the light was more than 50 degree in case of CFL. In case of LED, it was like less than 29 degree. So this also gives saving on cooling. So light not only saves in energy for lighting fixtures, but it also saves for cooling. These are the fixtures we have put it here for bifacial. You can just see it. This is the like rooftop, which has white color. This white color will have diffuse radiation, and this also falls back on the rear facade of the cell, so that cell generate energy from top side as well as the rear side. These are good BMS system, building management system, which will also ensure good saving, good control mechanism for a given system. And this is the performance of our building with regard to net zero energy. This example showcase, if I rotate my building for a given angle like 90 degree, further 90 degree, further 90, and then having the 100% rotation there like 360 degree or so, there would be difference in consumption. This consumption also gives saving which lasts with the whole lifespan of the building. This is a powerhouse which is located in Chennai. It is a true net zero energy building in design. I hope it is now completed and would be up and running maybe in a couple of months. But this building is like truly net zero energy platinum. If you want someone, you can visit, and you can also contact in case you find any difficulty there. This is again a project from ITPC, Radial Road, Chennai, which is also net zero energy. They have done like huge energy efficiency, then renewable energy on site, as well as remaining comes from the off site. This is the energy of a very large campus in Bangalore, which is located with more than 10 to 12 buildings in one site, and again huge energy efficiency. They have invested more than 21 crore rupees to retrofit several items there, and then try to improve the energy efficiency. Rest of the energy comes from on-site and off-site there. So there are many good things in Tamil Nadu, but many more things can happen through adoption of like net zero energy. So this was the presentation about net zero energy. If you feel any doubt, clarification, I would be really happy to help. Thank you, sir. I hope I took little more time, but I'm sorry.
Not at all. Thank you very much. perhaps even though you're traveling, maybe if we have some questions that you need to answer, we'll come back to you later and we'll
Absolutely,
contact
sir.
you
No problem.
over the phone. Yeah. Thank you. May I next call upon Dr. Ashwin Mahalingam? He's at the IIT Madras. And Dr. Ashwin, it's over to you.
Thank you, sir. Thank you, Dr. Raghunandan. Thank you, Kirti Bai, for both setting the context and inviting me to this. This is the second time I'm part of this webinar series, and I think it's wonderfully well put together. I learn quite a bit just listening to the other speakers, and that makes it very enjoyable. So to start off with, I have good news and bad news. The bad news is that a lot of what I wanted to say, both the earlier speakers, Dr. Raghunandan as well as Dr. Shivraj, have spoken quite a bit about it. But therefore, the good news is that maybe I may not need all of my 15 minutes and therefore might bring us back on time. I'm going to start with some of the things that so maybe just sort of recapping some of the things that Dr. Raghunandan spoke about, because I think that was very similar to how I wanted to open. Many years ago, about 20 odd years ago, I read an article called, quote unquote, "It's all in the architecture, stupid." Okay, that was the name of the article. It's all in the architecture, stupid. And the provocative title of that article essentially said, look, we're all concerned about global warming. We're all concerned about pollution. We're all concerned about resource depletion. But when we look for culprits, we typically look at these large industries, these smokestack and these vehicles that emit fumes into the atmosphere. But actually, one of the biggest sort of culprits in this sort of global warming carbon emission game are buildings, right? Or buildings or built facilities, infrastructure, and so on. And essentially, it said about those days about 50% of the emissions were really due to buildings, right? And so the question was, we've got to really look at buildings very, very seriously as we start tackling this, sort of global climate crisis that's upon us. So, one of the questions that Dr. Raghunandan proposed was, when we look at our NDCs, our nationally determined contributions, should we start as a component? I think absolutely. I don't think there are two ways about it. All right. Now, when we look at buildings, again, I think Dr. Raghunandan pointed out that when we look at energy in buildings, there are two components to this. There is something that we call the embodied energy, which is the energy that goes into the construction of the building. So every time you lay a brick or every time you pour a little bit of concrete, there is a lot of energy that has gone into that process. So for instance, when you take the example of concrete, somebody has mined limestone from somewhere, that has consumed a certain amount of energy that has sort of been transported, and using the limestone, there is a chemical process that occurs to convert it into cement. And in that process, limestone is calcium carbonate, emits carbon dioxide. So some carbon dioxide has gone into the atmosphere. Then that cement is loaded onto a truck. The truck then comes to your site. The truck runs on petrol or diesel most likely. And as it runs and it burns the diesel, more greenhouse gases are emitted into the atmosphere. So by the time you get that cement onto your site and mix it with water and aggregate and pour it onto your beam and column, there is quite a bit of energy that has been consumed and quite a bit of carbon that has been emitted, which we call the embodied energy. And the second component, which the previous speaker spoke very elaborately and comprehensively about, is what we call the operational energy, which is once the facility is built and you run the facility, then we're all probably in some kind of a facility today. I'm sitting in my office in Chennai. I've got a couple of lights running, I've got fans running, and all of this is consuming electricity. And most of this energy today is still coming from thermal, coal-fired power plants. And so as I get this electricity to run my lights and fans, I've got emissions that I am emitting into the atmosphere. So we've got these two components, the embodied energy and the operational energy. Now, when I look at net zero buildings, I feel we should reduce both of those. And that was also the point that Dr. Raghunandan was making. But somewhere, I think we seem to be a little bit more obsessed with the operational side of things. than we are with the embodied side of things. So if you look at the previous presentations, we have all these kinds of schemes and ideas on how do we reduce operational emissions. How do you, for instance, replace your power source with clean power? How do you come up with more energy efficient appliances and things like that? How do you sort of bring down the footprint of your emissions? And we don't quite spend the same amount of time talking about the embodied energy. And so I wanted to talk about both of these holistically. So if I were to design a net zero building, typically when you design a building, the first person who sort of, or the first professional who lays a few stones in the ground or lays a few markers in the ground in terms of how that building will perform is the architect. And the architect typically comes up with, as was shown in the previous presentation, certain strategies, particularly passive strategies that will lower the energy demands on the building. So they might sort of orient your building in a particular way so that you get more natural daylighting, and therefore you might need to use your fans, use your lights lesser, or they might orient it in such a manner that the building becomes cooler, and that the fenestration and window design might be such that you may not need air conditioning as much, and therefore you lower your energy load. So on the one hand, there is a passive design component that architects bring in. But typically once the architect creates a form, you have a structural engineer that comes in. And in my view, the structural engineer now has to start thinking sustainably. And there are at least two things that the structural engineer needs to start thinking about. Thing number one is when you design your members, your beams and your columns and so on, how can you design these to be the slenderest, slimmest, sort of thinnest members possible that can still, of course, fit with the codal provisions, that can still, of course, bear the load, because the lower the volume of your member, the lesser the material that you're consuming. And that starts bringing down the embodied energy of your building. And very often I find that from a structural perspective, we don't necessarily pay attention to sustainability. Of course, we want good load bearing capacity. So we want to sort of design these to be stable structures, but in some sense, many of these structures are over designed, which means we're putting in more material into it, emitting more carbon as we start building these structures. So one is from just from a dimensional perspective, from a load bearing perspective, how can we come with innovative shapes, forms, etc., that reduce the total quantum of material? The second aspect to think about is, whatever the quantum of material is, what is the most sustainable kind of material that I can use that will reduce again my embodied footprint? So we all know that traditional cement, the ordinary Portland cement, or the OPC as we call it, tends to emit a lot of carbon dioxide because of the reasons that I just sort of gave a few minutes ago, right? So just by the process of converting calcium carbonate into calcium oxide, carbon dioxide gets put into the atmosphere, things like that. So there is a certain footprint. Now there are, of course, several substitutes that are available where you are able to replace parts of cement with other kinds of material to bring down the overall footprint of that construction material if you're using cement. And again, it's the same. So we use a lot of steel in our buildings, both for reinforcement, more and more structural steel is being used in a number of buildings, etc. Again, the steel production process, if you're using things like hydrogen to generate that kind of energy, you're getting cleaner and greener kind of steel. So the question is, can you start designing buildings with greener materials, with lower footprints? But also, can you start from a structural perspective designing buildings with greater durability? A building that lasts 50 years will be brought down in 50 years and another building will be built in its place. And the second building will again consume embodied energy. But if I build a highly durable building that lasts for 100 years, then I don't have to take the building down and rebuild it again. So my overall embodied energy over those 100 years comes down. So I think the material scientists and the structural engineers have a huge role to play in this, in this scenario. And then, of course, once the structural engineer has done their job, you have the mechanical and electrical engineers who typically come in and start looking at the HVAC systems and things like this, which of course they sort of need to then optimize and design so that you get more efficiency and things like that, that of course play a part in the operational emissions. All right. But the story doesn't end there. Once you have a design, you have a contractor that's actually going to come and construct. And the process of construction uses quite a bit of energy. You have all of these large equipment, lifting equipment like cranes, digging equipment like excavators, and all of these are consuming energy and emitting carbon into the atmosphere. So the question one needs to ask is, how do I make my construction processes more efficient? So at IIT Madras, we've been working on this concept of lean construction for quite some time, which is highly synchronized construction, right? Where people do not wait, where you do not have excess inventory and sort of things move like clockwork. And it turns out that lean can actually be green, because the more synchronized construction is, the less an equipment is idling and emitting carbon dioxide without doing anything productive and things like that. So we've got to pay close attention to the construction process as well. So the contractor has the role to play. And then finally, when you start operating the building, it's not enough to just have designed all of these kinds of things. The people who use that building need to behave in a sustainable fashion. So I can come up with the most energy efficient light and fan fixtures, but if the person leaves the light and fans on a Friday evening and comes back on Monday morning, then that's not being very sustainable either. So then there is a behavioral component. So I think in order to really have a net zero building, we need architects who can design with really good passive and active strategies, structural engineers who can sort of try to minimize the volume, but also maximize the sustainability of the materials that they use and the durability of the structure, mechanical and electrical engineers that design very efficient building systems, construction professionals who are able to optimize the construction process, and finally, users who then behave in a manner that is befitting sustainability and therefore finally bring down the operational footprint. Now, in order to achieve all of this, I think there are a couple of things that we've got to look at. One is, currently our procurement processes, or the process of project delivery, as we call it, is extremely sequential and fragmented. The architect passes something on to the structural engineer, then to the mechanical engineer, etc. So the further down the chain you are, the more constrained you are and the less scope you have for innovation. So I think we have to change our service delivery frameworks to take a more integrated approach where users, architects, contractors, etc. are jointly making decisions right from the get-go. There are several frameworks. Integrated project delivery is one, and there are a few others that we can talk about, alliance contracting if you like. But there are ways in which we have to sort of think in a more systematic and collaborative manner. So that's point number one. Behavioral change, of course, is something that I'm very passionate about, that we've got to think about. And third, we need to start measuring, right? Because if you don't measure, you have no idea what you're doing. To some extent, on the operational side, we are measuring. So in the previous slide, you actually saw numbers, you saw benchmarks. But on the embodied side, we are not measuring anything at all. So there are, for instance, techniques like there is this thing called life cycle analysis, LCA, right? Which actually measures the carbon footprint of bringing one brick to your building, right? From the time, sort of something was taken out of the earth's crust and baked and transported and brought to your site and laid, you can actually calculate using these life cycle analysis techniques the total amount of emission. And for each building or structure that you build, you can actually do a life cycle analysis to understand what is the total amount of carbon that you've emitted. Now, what would be really nice if we started doing this for all our buildings, and if we said, hey, Ashwin, you're now in a building at IIT Madras. It's an academic building. It's a civil engineering department. It's sort of got so many square feet, and this is the amount of carbon you emitted. So the amount of carbon per square foot for the building sciences block at IIT Madras is so much. Once we have that kind of a benchmark in place, then we can slowly start competing with ourselves to beat those benchmarks. The next building I build, or the next building you build, or somebody else will build, can say, this was the IIT Madras benchmark. How do I become 2% better in terms of my emissions? What new material can I use? What design innovation can I use? What passive strategies can I use? And so on. And over a period of time, and then that becomes the next benchmark. And somebody else says, okay, how can I beat that by 2%? So I think this measuring and benchmarking is going to be critical for us to look at net zero buildings. So I'm going to stop here because I don't want to sort of take up too much time, and perhaps we can come back to this with some Q&A. But just in summary, I think net zero buildings is more than just the operational energy. It is the embodied and operational energy. We've got to put both together. We need to think systemically, and we need to sort of benchmark and measure. And if we can do all of this, and this requires not just technical change, it's not just engineers, it requires social change, behavioral change. The social scientists among us need to start coming into play. I think we can make a significant difference. And again, to Dr. Raghunandan's point, I think this could really be an important part of our NDCs and things like that. And to me, Tamil Nadu, Chennai, where I stay, there's no reason why Chennai or any other part of the country should not, start going on this bandwagon. Of course, it has to be accompanied by regulation and things like that, and we can talk about all of that later. So let me stop with that. I hope I didn't overshoot my time very much, sir. Hand it over back to you.
Thank you very much, Dr. Ashwin, for excellent presentation. I think you also tackled so many of the issues that really go into it, because somewhere, we all have to understand that issues we are looking at are not just technical, but the issues are social, they are managerial, they are behavioral, and they are policy related issues. All of that need to come together if we are to achieve anything. Anybody can screw in a different kind of a light bulb, but that alone does not make a building energy efficient. So thank you. I think we'll come back later with some Q&A. I will now invite Dr. Sampath Kumar to make his presentation. As I understand it, he is going to address a very important part of the embodied emissions, which is now going to come into the ECBC, and he's going to talk about water, if I'm not mistaken. But it's over to you, Dr. Sampath.
Thank you, sir. Am I audible, sir?
Yes.
I think there's some issue with the video. Somehow, though it is on, I think it's.
It'll come. It'll come.
But I'm going ahead with my presentation, sir.
Yes, go ahead.
Yeah, thank you. Yeah, I hope my screen is visible, sir, fully now, with full screen.
Yes, sir.
Yeah, thank you. Yeah. I'm Sampath. I'm leading the Net Zero initiatives at IGBC. My colleague Shivraj also explained a bit about on energy, but their water, waste, and carbon, which Dr. Mahalingam also emphasized. So, but today I'm trying to cover on what we are looking at from water perspective. And let me share very few slides about our own journey. We started working on buildings, we moved on to built environment. And then we realized that, we need to work on net zero buildings. And that's how we started focusing on net zero buildings, a focus with the mission mode. And I'm glad to share that with our own center being the first platinum rated building and net zero energy building now, we have more than 13,000 green building project with about 11 billion square feet. But the message from this slide is we started working exclusively on net zero projects, and I'm glad to share that we have 100 plus projects which are working exclusively on net zero. This number appears to be small, but we are getting many queries. Earlier, a couple of years back, even if we used to get hardly a query on net zero. But today we get more than 5 to 6 queries on net zero projects, which is good. We're trying to understand what are the challenges, opportunities, what are the policy changes which we are looking for from different states or central government. All of this is helping us to work toward net zero. And then IGBC has launched a mission on net zero. What we thought is we should facilitate the net zero movement in a holistic way. And in the year 2021, on the Earth Day, April 22nd, we launched IGBC's mission on net zero with a vision to facilitate India to become one of the foremost countries in transforming to net zero by 2050. And India is one of those countries. We're working on net zero buildings in all aspects, that is energy, water, waste, and carbon. And when we launched this, and over a period of time, we had a commitment from over 350 organizations to achieve net zero status for their new and existing buildings. Of course, many of these organizations are yet to demonstrate their buildings as net zero, but they made a commitment that they will start now, and sooner or later they'll want to become a net zero. And we have, as mentioned earlier, we have launched exclusive rating tools for net zero energy, net zero water, net zero waste, and net zero carbon. For a period of 5 years, we took a feedback from the industry leaders, experts, projects, consultants, manufacturers, academicians on different subjects. And then we developed these rating tools slowly over a period of 5 years with the intent that the industry should look at energy, water, waste, and carbon. And of course, carbon, we're looking in a holistic way, because it's not just energy which will reduce the carbon emissions. There's a nexus between energy, water, and waste. And that's what we're trying to focus with net zero carbon. But today, I would focus on water. That's where, and of course, water is directly linked with energy. That means the more the water we use, the more the energy consumption, and the more the energy consumption leads to higher energy carbon emissions. So what is that we are trying to look at? What is the approach and methodology we have for projects, how they can look at net zero water? And particularly Chennai, I mean, it's very unique in terms, we have seen floods where we have a lot of water, and at the same time, we have water crisis in Chennai. So it's a very unique scenario which we look at particularly from Chennai and other parts of Tamil Nadu. Let me share some of those concepts which can be considered by the projects. So net zero water, I mean, for any net zero rating when we developed, the first thing what we looked at is the definition, because that's what we have to focus to define how we can address the projects from net zero. So what we have defined the net zero water based on the consensus and the views which we have received from the industry leaders and experts is that net zero projects are those that consume minimum raw water. I mean, some of the important things I've highlighted, I mean, underlined here: minimum raw water and produce alternate water to meet the balance requirement. That means we use minimum water and produce alternate water to meet the balance requirement, and then give back alternate water to original sources for use, so that the net annual water consumption is zero. The definition might be complex. I'll try to simplify this. In a nutshell, what we're trying to say is we have to know what is our total water consumption. And then we have to know what is the alternate water which is being used or harvested, so as to figure out what is the raw water consumption. So for this, first of all, the foremost thing is, like similar to energy meters, we need water meters. And this is one of the biggest challenge we have when we ask projects, do you know the water consumption in for each of the applications? For example, like, do you know how much of raw water is used, how much of treated water is used, or how much of water is used for cooling towers or flushing or landscaping or any other major applications? The answer is, yeah, we know the total water, but we don't know breakup. So what I'm trying to say is, unless we measure what is being used, we can't enhance the performance. So we have classified what is raw water and alternate water, so that projects know very clearly this is how we can look at. So a combination of raw water and alternate water gives us the total water consumption. So the raw water, which we typically know, is municipal water. Even borewell water, if it is not potable, we still consider as raw water because it is taken from the Mother Earth. And then, of course, the alternate route is, tanker water, which is being purchased, particularly in these months of summer, and it is huge demand. And we are seeing the news, day in, day out in different cities like Bangalore, Chennai, and Hyderabad, and many other cities. And alternate water, rainwater, which is harvested, that is the stored water, or the treated grey water. And some of the projects where the cooling towers are used for HEC makeup, where we have the condensate water, or even from the HUs, which are used even if air cooled, and any purchased grey water. Some of the authorities, I mean, they sell the treated water for projects to use, not only for construction, but for the building use, the regular operations as well. So on this note, let me share, we have defined net zero water in 3 levels: net zero water, near net zero water, and net positive water. But the message from this slide is you have to look at 2 parameters. One is water performance ratio, and the other is water back to source. Water performance ratio and water back to source. So these are the 2 important parameters. I'll get back to these numbers a bit later. What is water performance ratio? My colleague Shivraj explained about energy performance index, which is like energy performance ratio, which we can, or water performance ratio. So what we are defining water performance ratio is alternate water consumption to total water consumption. We have understood what is alternate water. So we're trying to come up with the ratio of alternate water to total water. So once we know this, we may be in some number which is maybe 0.5, 0.6, 0.7, but we need to know where we are so that we can take measures how we can enhance the water performance ratio. The water performance ratio should be higher the better. So how we can enhance the water performance ratio is by reducing the water demand. Like how we were talking about energy demand, we have to reduce the water demand, and by harnessing alternate water. So let me get in a very high level overview how we can reduce water demand. The first and foremost is having a water management system. We all heard about energy management systems, but there's a lot of demand for water management systems now. So these water management systems is a dashboard wherein we have the digital water meters, and every second, every minute we get the data from these meters for different applications within the buildings or within the campuses to figure out what is the water consumption for different applications and what is the total water consumption, and for what applications in which buildings, everything will get to know. So that water is monitored every minute. So we know where are we with respect to the benchmarks. And then water efficient fixtures. I mean, this is the most important thing. First, unless we have efficient water fixtures, we can't reduce the water consumption. We have heard many of the projects saying we have a lot of treated water, so we are not worried about using water. But even if you have excess treated water, we need to conserve water, and what is excess treated water can be donated or can be supplied for other buildings or for other applications, so that overall water demand can be reduced. So having water efficient fixtures for different applications, like we have conventional urinals, we can retrofit with sensor-based urinals, or urinals with efficient aerators, or waterless urinals, so that we are avoiding the water completely. Instead of using single flush systems, we can go with dual flush systems. Even we have seen projects, they use a single flush system with 10 liters of water, wherein we can even go with a standard 6x3, which is available, or we can look at 5x3 flush systems. And then, of course, aerators, which can work wonders. And we have seen several projects being retrofitted now, particularly in the case of Bangalore, where even the government buildings have mandated to be retrofitted the flow fixtures. So the aerators, though they are in small in size, can make a big impact. So a conventional tap which can consume 8 to 10 liters of water, with aerators it could be as low as 1 to 2 liters per minute. So of course, for health faucets and shower heads we have seen with 10 to 15 liters, which can be reduced to as low as 6 to 8 liters. So there are different ways and means to reduce the water consumption through water efficient fixtures. That's what we are trying to say. And then water efficient landscape and irrigation systems. We have seen several projects where they have beautiful landscape, but they are water guzzlers. These landscapes which are there are water guzzlers. They consume huge quantities of water every day, particularly the summers. So first, the thing is we have to choose the plants which consume less water, and we call them as drought tolerant species or native species, or we have xeriscaping, which means the water consumption by these plants is very minimal. On top of it, if we can add on irrigation systems like sprinklers, drip irrigation systems, timer-based controls, pressure regulating valves, moisture sensor controls, this will further reduce the water demand. So in a nutshell, what we're trying to say is we have to have different strategies to reduce the water demand so that overall water consumption in the project is reduced. Assuming a project is consuming 10,000 liters of water per day, what is that we can do to reduce the 10,000 liters of water per day, say to 8,000 liters or 6,000 liters? That's the first thing which we need to look at. And then we can, whatever the waste water which is being generated, we have looked at, if a building consumes, say 10,000 liters of water, and assuming even if there are some losses, say 9,000 or 9,500 liters of water is going into the wastewater treatment plant, excluding the water which is used for drinking and landscape applications. right? So how can we treat this water efficiently? We have seen several projects. One, they have STPs which don't operate, or they have STP which operate at about 25 to 40% efficiency, or at max 50% efficiency. What can we do to improve the performance of these wastewater treatment plants so that 70 to 90% of water is treated, and that water is again reused for different applications? So the water should be treated to tertiary standards or secondary level. For example, secondary level can be used for landscaping as it is, but tertiary we can use for flashing and cooling tower also, so that overall water demand can be reduced. And then storage of rainwater. We have seen several projects again, they have very minimal storage capacities, or they don't have storage capacities at all. But we recommend whatever is possible. We're not trying to say harvest complete water, but whatever can be reused for that particular day or the next day, that quantities can be stored, that water. Because in fact, unlike energy, water is not priced the same way. But the moment we look at the water is being priced, in fact, probably the emphasis is more on towards water. But when we look at the math with respect to the water which is being supplied by the municipality, which is bare minimum cost vis-a-vis the tanker cost, or when there's no availability of water, that's when we value the water. So the storage of water plays a big role even when there's a rainfall. That water which is being stored can be used on the alternate days. So wastewater can be looked at different ways. We have, the conventional ways of biological treatment, phytoremediation, treat zone. I don't go into details, but these are natural ways of treatment where we use the plants to use the treat the water. And then we have the mechanical systems where we have high-end mechanical systems where the water can be treated to 90 to 95% efficiency as well. And rainwater harvesting, we know these measures, we can collect water in a pond, even in campuses, or storage tanks, even in a residential building or a residential bungalow. And then percolating water to the ground. I mean, this is something which is done very, very well in most of the projects. And some of the projects, we have a pit, that's it. So if you look at the other one, the water back to source, again, we have a ratio, water performance ratio. Water back to source ratio is water recharged vis-a-vis the total raw water consumption. So we have come with an equation here. Whatever the raw water which is being consumed in the project, raw water, in addition to the alternate water, whatever the raw water which is being consumed, that equivalent of water, if it is recharged to the Mother Earth, that means whatever water we are taking, we are giving back to Mother Earth, then we can look at from a net zero perspective. So let me explain here water back to source. We discussed a while ago about rainwater harvesting, where recharging is one of the strategy. So recharging can be done. And if you have excess water on a daily basis, particularly say residential communities, they use more of the raw water for use on a daily use, domestic water, and they have excess water which may not be used for reuse for like flushing or landscaping. That excess water can be donated, or it can be even sold to others who require this water on a daily basis. It can be preferably through a piped connection, or if possible through tankers, because there's no alternative way to divert water as of now. But we need the infrastructure from the municipalities to supply this treated water to all the buildings, whether it is commercial building or residential or industrial buildings. Even donating this water is for a useful purpose can be considered water back to source. So coming back, the near net zero, and net positive. We were discussing about water performance ratio and water back to source. So we have put some numbers based on the feedback we received from the projects and our own analysis. So if the projects have a water performance ratio of 0.75 or higher, that's when we can start looking at net zero, near net zero, or water back to source of minimum 0.75. In case if they're not looking at water performance ratio. So we have some numbers here. I mean, I'm not trying to focus much on the numbers, but there's a strategy to look at in terms of water performance ratio and water back to source, so that we can achieve the near net zero, and net positive projects. And we have several projects now, taking this challenge to become near net zero or net zero, and very, very few projects with net positive. So we have come up with a checklist. I will not get into the details, but the message from these slides is it's not like one strategy applies to, become net zero. There are several measures to be considered, and we have put in weightage for these measures on a scale of 100, so that the projects can look at all of these measures and see how they can look at a net zero water for their projects. So let me quickly share a couple of case studies so that you can understand how projects are looking at. This project, which is Soba in Thrissur, is the first project which we have certified as net water positive. Of course, is one of a case. This project is in the state of Kerala, where there is abundant rainfall. But taking that into account, the project have made a man-made lake to harvest the rainwater, and they made a lake of about 6.5 lakh liters of water, which will shrink whenever there's no water, when it will fill up when there's a lot of water. So they are holding about 191 million liters of water. I mean, this project would have thought, we can make some other units and, make more money. But they had an opportunity to make a huge water body which can harvest the water. That water is being supplied to the dwelling units and further applications. And in fact, this project effectively is giving 20% additional water back to source, in addition to the water what they have already consumed. So that made the project to become a net positive. And another project of Chennai, which is a radial IoT park, which my colleague already mentioned about from energy perspective. This project is very unique because they achieved the net zero, water for design, but the same project have applied for new building rating for platinum. And they got, a decent infrastructure for from water perspective. But then when they started looking at net zero water, the perspective changed, because the criteria we were looking at was far more stringent for project to comply. Say, for instance, they had only 14 number of pits earlier, and they had half the size of the pits. We had to make them increase the size of pits and also increase the number of pits to 28. So, and now they are able to harvest, the capacities are, they can harvest about 15,000 cubic meters of water annually. And then they have an STP, which was working, for project, which is for platinum rated and net zero. But again, what was the difference was storage tank. There was about 250 cubic meters, but they had to increase to 1,000 cubic meters so as to store the water and reuse in the building. So that what we are trying to say from this is, conventional projects, and then when you're looking at the net zero water projects, they have to look at it in a different perspective. That's what we're trying to say here. So there are quite a lot of organizations which have taken up this challenge. They have taken pilot projects from energy, water, waste, or even carbon now, including L&T, which is based in Chennai, the headquarters for L&T construction. So different projects have taken the challenge. The message what we're trying to say is, some may look at priority as energy, some may look at water, some may look at waste to landfill or carbon, but somewhere we need to start. So what is relevant, what is applicable can be taken into consideration. The point I'm trying to say is, certain projects, they can't take up net zero water because they have limitations in site conditions or the infrastructure which is there locally, or say energy. Even if they want to become net zero energy, the local policies may not favor. Or if they want to become net zero waste into landfill, they are doing very good, but they don't have recyclers who can take this waste and process the waste. So we can look at what is more realistic and then look at how we can become a net zero energy, water or waste. So to sum up, this is an excellent opportunity to demonstrate leadership in net zero for everyone, but we need to start somewhere so that we can benchmark and then make others to embrace net zero concepts. There's a clear demonstration of operational cost savings, and then green makes business sense, but net zero makes all the more business sense for the projects. And then, of course, more importantly, whoever is embarking the net zero journey, they will contribute to India's commitment to become net zero by 2070, which the country has committed. So this is all about a small short presentation on net zero water and what we are doing from net zero initiatives. Thank you. Over to you, sir.
Thank you. Thank you very much, Mr. Sampath, for that lovely presentation. Now, what I'm going to do is, we have in our ClimACT project, we have conducted a fairly intensive study of what is going on in Chennai. May I ask my colleague Chitrakshi to please share my presentation, the last one. So I'd like to share with you some of the work that we have done on this particular aspect. I am stepping in on this because our researcher who had worked on this, on the buildings sector, Sai Varshini, she has left for higher studies abroad in Germany. And since I was sort of helping steering the project in all the sectors, I thought I could step in and do the presentation on our behalf, because the others on our project were not feeling that confident in the sector, not having worked on it. So I'll make this presentation fairly quickly. Next, please. We don't need this. Yeah, so this is basically what we have done in our study, which we call the approach paper to climate action. That's available on our website. You can see the address there below, where we have looked at the existing context, climate change impacts, adaptation, resilience, and emissions reduction potential across different sectors. We've also taken into account the Chennai Corporation's climate action plan and looked at possible gaps, improvements, etc., which we have then responded to in our study. A unique aspect of our study is each of the sectors that we have looked at, the perspective we have adopted is to look at co-benefits. That is to say, you aim, for example, at reducing energy, but it also helps you save water. It also helps you save pollution. It also helps to reduce heat in the city, etc. So each of the sectors we are looking at co-benefits, both within mitigation and adaptation or across mitigation and adaptation. And I'd just like to say, for those who are likely to read this from our website, this is the first iteration, and we hope to continue and improve this through interaction with other stakeholders. Next, please. Yeah, so these are the different sectors that we have covered in that, and today I'm concentrating on buildings, including energy use inside the buildings. I'm only looking at what we have described as operational emissions and energy use, not on the embodied side of it. Next, please. Yeah, next, please. Yeah, so we've been made very familiar with this distinction between the embodied and the operational emissions. So I don't need to go into that. I think Dr. Ashwin has explained this very well. Next, please. Yeah, so we know that the building itself is a problem, apart from fittings and the appliances inside that. And we've heard about how different materials, different designs of the envelope, etc., need to be done. Simple observation of today's buildings are we seem to go in the opposite direction to where we should be doing. We use a lot of glass where we don't need it, where only traps heat, etc. So that's one part of it. The other part of it is the electricity usage inside buildings. You know, earlier, the Eco Nivas Samhita norms, codes, were not introduced because it was thought that residential buildings are not such a big sector. But newer data seems to suggest that residential buildings may be consuming about 75% of total energy consumed in buildings. And that has then refocused attention on residential sector, which we haven't heard much of today. So I'd like to focus a little bit on that. Next, please. Yeah, I'd just like to speak a minute about this. See, there is a very important sort of feedback loop that takes place between urban heat and the use of appliances, especially for cooling, etc., inside buildings. Now, we all know that in cities and urban built structure, buildings, roads, and other infrastructure absorb heat and re-emit them into the ambient environment of the city, which leads to what we call the urban heat island effect. Now, the hotter the city gets, the more you need to use ACs or other cooling devices. But the more you use ACs, for instance, the ACs exhaust heat in exchange for the cooling that they do, which adds to urban heat, and you get more urban heat. And the more the urban heat goes up, the more you want to use ACs, which drive up your UHI even more. So this feedback loop takes place, and we need to be conscious of this, that reduction in energy used for cooling inside buildings not only helps save energy, it also helps save the urban heat in the city and to improve livability there. Next, please. Yeah, so saving energy and emissions, as we have been discussing there are different aspects of this, embodied as well as organizational. The regulatory systems are really not yet mature enough to get into this. Those who are doing it voluntarily, fine. Gradually, we are moving towards mandatory regulations, particularly for commercial buildings. But any kind of mandates or strict regulations in residential buildings is yet to see the light of day, which may change in the coming year or so to broaden the scope of the building regulations, as well as to make sure that compliance is required rather than voluntary as it is now. Next, please. Chitrakshi, next, please. Yeah. So there is obviously a big growth in the building sector, both in residential as well as commercial. We don't have numbers for it, but there's going to be a huge demand in Chennai city, for example. It's expected that apart from residential expansion, which is taking place at more than 10% per annum cumulative growth rate, commercial and office buildings are also growing at an explosive rate, given the kind of industrial growth we are seeing in and around Chennai and the greater metropolitan area. Emissions from the buildings in Chennai are about 57% of total emissions inside the city. And I'm only talking operational emissions here, not even embodied emissions. Out of that, residential is about 31%. I'm not looking at LPG and cooking gas. And commercial buildings are about 26% of the total. So the big challenge is here you've got easily more than half the emissions in the city coming from buildings, but we are not yet taking major steps to control those. Next, please. Yeah. So this is a huge problem. It cannot be sort of wished away or pushed back, and the need is for policy and tactical solutions. How do you implement what you want to achieve? Next, please. Yeah, so what we have proposed in our study, I'll run you through those very quickly. The first is with regard to building envelopes. The Chennai Climate Action Plan has proposed targets in which they have combined retrofitting and as well as new buildings. And they have set some targets, which you can see the numbers there. We feel that perhaps this is not particularly wise from an implementation point of view, that firstly, we should look at commercial and residential buildings separately, because your implementability is different, compliance with regulations is different, and we also should look at new buildings and retrofitted buildings differently, especially in residential sector, for example. If retrofitting involves fixtures and lighting, etc., that's easier. But if it involves changes in the envelope, that's not easy to achieve at all. So therefore, I think the strategy for implementation needs to be segregated in commercial, residential, as well as new and retrofitted. That needs to be looked at. And new buildings clearly will be able to give you better energy savings, because all the aspects can be taken care of, including the design, envelope, etc. And the co-benefits achieved from this would be lower urban heat, lower power demand from it, as well as a win-win for builders, etc. I'll come to that. Next, please. Yeah. So now I'd like to look at the ACs and other appliances. We haven't looked at that so much. We've taken for granted that these efficiencies are easy. You look at 3-star, 4-star, 5-star, you put them in and you will achieve that. However, we feel that actually the amount of energy savings and emission savings, therefore, from air conditioning is quite underestimated. The Chennai Climate Action Plan also has estimated something like a 3% saving on emissions from energy efficient ACs. Now, we think this is a fairly gross underestimate of that. We think it's closer to 10% overall. And therefore, if you have estimated properly, you can give, or there's an incentive for a much greater push to energy efficient ACs. For instance, you can have mandates for new buildings which say, this is the minimum efficiency your air conditioners should have. Something else that has happened, for example, in Delhi is the electricity distribution company is offering discounts and incentives to all residential building owners, saying, we will replace your air conditioners with higher star rated air conditioners. We will help you with refinancing by building in the EMI into your electricity bill. And they are doing this not for altruistic reasons, but because it lessens their load, the requirement to purchase power from other states, etc. So therefore, it's a win-win. The distribution company wins, the consumer wins, the energy sector and emission sector wins, because you have upgraded all the system towards a higher thing. The other aspect which Dr. Ashwin mentioned, which is the behavioral aspect, this is also highly underestimated in our country and also in the Chennai Climate Action Plan. Many other countries have experimented with this. Shanghai, for example, Tokyo, Seoul, Bangkok. What they have done is they have put mandates, that is, it's compulsory in large offices and commercial buildings to set your thermostat in the AC at 25 Celsius. Now, as you know, in Delhi, temperatures will go up to 44, 45. In Madras, close to 40. In Delhi, the habit is people like to shiver when the summer is at peak outside at 44, 45. They like to wrap themselves in a blanket and stay in an air-conditioned room with the setting on the AC at 19 degrees or 20 degrees Celsius. These rules in Shanghai, Seoul, etc. have said 25 is the minimum. You can't go lower than that. And that has made a huge difference in the consumption. And they have recorded that urban heat has come down by 2 to 2.5% from this one measure alone. And we have estimated that you can improve the energy efficiency and emission savings inside the building by close to 10 to 15% by behavioral changes in use of air conditioning, which can be done through mandates as well as through information campaigns, awareness campaigns among residents in building societies, and so on. The same thing can be done with energy efficient televisions, refrigerators, fans, LED sets, etc. Together with changes in the building envelopes, we think that this can overall translate to about 30 to 40% savings in emissions, which I think is huge, which is achievable. But as I said, with proper tactical moves to incentivize these moves, to have mandates, which I think without which new building envelopes conforming to ENS will not get built. So mandates, we believe, are necessary, and we would like to engage in advocacy towards that end in the amended ECBC and ENS system that comes in. And as I was saying, these sets of proposals, I won't go into the numbers. Those who are interested can look at our document on our website. but it has significant co-benefits. It, of course, saves energy and saves emissions. Those are the main benefits, but there are significant co-benefits in this. The first is it contributes to lowering the urban heat island. And our estimation is that if you take these measures, you can actually lower the urban heat island effect in Chennai by close to 2 to 2.5 degrees Celsius, which is a significant number that we are talking of. Second, of course, there is efficient power usage in this, which is going to become significant. Today, it's thermal power. Tomorrow, if you replace it by solar, there are challenges within that as well. So the lower your power demand, the better it is going to be. And as I said, it can be a win-win for builders, for appliance manufacturers, for users, and for utilities in that. Next, please. So I will close my brief presentation here. I think what we have done through our study is to explore these options and to highlight that the benefits obtainable through improvements in building envelope, shift in building envelope, particularly in residential buildings. Commercial buildings are likely to follow their own logic, likely to comply with norms sooner than in residential buildings. Governments also may hesitate to enforce norms on residential rather than, but all our estimations show that the payback period through energy savings and therefore on your expenditure on this will pay back within a not very long period of time. Anywhere between 5 to 7 years is roughly the payback period that we estimate, which is not much, which will save you a lot of emissions and a lot of energy and improve livability in the city through lowering the urban heat island effect. So I'm going to stop there. And we have about 15 minutes there for any Q&A, etc. that may come up. Our old friend Michael, who's a faithful follower of these webinars, I thank him for his continued presence and his remarks. And he will give not only here on this, but later by email. I'm sure he will give us a lot of insights and suggestions in the future. So what he's put up in the Q&A is that he's talking about low-income housing, and to reduce cost, we make apartments smaller and thinner envelopes, and therefore the heat flow in the building is affected. Similar problems, of course, with sun-facing walls, and we've discussed that in the first presentation in terms of orientation of the building. He's absolutely right about orientation. Incidentally, by the way, I've read sufficient material on Chennai, which says that not only from orientation, but also from the way buildings have come up, that the sea breeze, which used to cool Chennai in the afternoons and evenings, is less perceptible now than it used to be because of obstructions in airflow posed by buildings and posed by the orientations of the buildings as well. So he's touched on that, and walls can be shaded, of course, which is true, and all of which reduce the use of cooling devices. So this question is there, his comment is there. Any of the other panelists want to respond to this, please? You're welcome. If Professor Ashwin wants to respond to this. Yeah,
I just wanted to quickly say, I think it's a fantastic comment, and I think your observations are also spot on about the sea breeze and all of that. I just wanted to, I had spoken when I had made my remarks about how we should reduce the dimensions of the members so that you reduce embodied energy. But what this comment brings out is, if you just do that blindly, then you might have this issue of very thin envelopes and issues with regards to, heat gain and extra cooling load, etc.
Yeah.
So this is where I want to go back to the point that I made is you need architects and structural engineers and HVAC mechanical experts to be able to design iteratively and not linearly if you want to, simultaneously solve both the material problem as well as the heating cooling problem. So I think it's an excellent comment. Just wanted to make that point.
Quite right. Thank you. I don't see any other questions or anything there. I have a question which other participants with other panelists may like to respond to, which is this issue of how do we go about implementing what we want. Now, in my presentation, I touched upon some aspects with regard to use of ACs, behavioral change, etc., and the role of mandates there. Historically, I think in India, we have been a little reluctant on mandates, thinking that this is not the best way to get compliance. It is better to, however, I have a slightly different opinion, and I've expressed that by saying that I think mandates in several of these contexts are useful and play an important role, particularly if you make clear to the user that this is not going to cost him much. For instance, our mandates in several cities now making rainwater harvesting compulsory, etc. So we have used mandates, and I think we should explore the possibility of using mandates to push for energy efficient building envelopes, along with all the other issues that we have spoken of, and particularly on the use of appliances and upgrading of those appliances today. Anybody wants to respond to that?
Again, sir, I'd like to quickly just say a couple of things. Again, I
Please.
think you're spot on. Typically, I think when we look at, you can, whenever you want to sort of incentivize behavior in a certain direction, there's the carrot and there's the stick.
Yeah.
So I think we have to judiciously look at both. The stick is in terms of, you have these mandates and perhaps there are mild penalties to, or some kind of penalties to not using these kinds of kinds of technologies. But of course, sometimes penalties is not really a great way to go. So I think the question is, we've got to look at what are the kinds of carrots that we can give that can incentivize adoption.
Right.
So for instance, is there some kind of a some kind of an advantage on the registration of a property or something like that you give, depending on the relative greenness of the property. Of course, there is always an inherent saving, because once you have an energy efficient fixture, you're going to be saving on your monthly electricity bill anyway. So that is automatic. But on top of that, for instance, in the granting of planning permissions, if there is, perhaps it can be done faster if your buildings are greener. So I think we have to think a little bit about the carrot side of things as well. And if we balance carrot and stick, if there are incentives and in the form of, say, carbon credits, and disincentives in the form of carbon taxes, etc., slowly we nudge behavior, I think, in the right direction.
Quite right. In Delhi, one of the things that is being experimented with is you show efficiency in energy or water consumption because of a calibrated slab system. The more efficient your electricity usage, if you bring it down below a certain amount, then your slab rate is lower. The same is true for water. Whereas if you are profligate users, then you enter the next higher slab where your rates are higher. The self-incentive part, which you touched on, is absolutely right. That is why people have the star rating on ACs. You spend more in buying a 5-star AC than a 3-star one, but you recover that cost through the electricity savings over a period of 1 year or 2 years, etc. And I think this is a very useful thing. And the third thing which Delhi is experimenting with is to lower your property tax depending on the energy consumption in the building or the efficiency of the appliances that you use. Are there any other questions any of the other panelists have which they'd like to put forward, or comments? Kirtibai, if there are any comments that you'd like to make or questions you'd like to pose to any of the panelists?
Do you hear me?
Yes.
Ashwin Saab, I think I wanted to tell you a small little kind of thing. Before earthquake in Gujarat, and I'm a practicing architect, a builder would give a job to an architect who would ensure that building is done in 1.5 kilogram per square foot. That was the criteria. And after earthquake, that particular number has gone from 1.5 to approximately 4 kilograms per acre, per square foot.
Wow.
And I honestly, I do understand that earthquake needs to be considered, and I think its impact, and it would impact on the use of the steel. But I have a sense that something is wrong somewhere. It couldn't, because the building were built and remained and lasted for decades. You don't have to kind of take it from 1.5 to 4. So I'm essentially making a point about a regulatory system and framework, and I thought you would have something to say. But let me kind of make another related point. And that is this. Once again, I'm practicing architect and work with structural engineers all the time. Now, I'm sure you know that the structural consultants do calculation of loads and live load and dead load and all that, and design the sizes. And then, and how much stay will it go? And then they apply what they call factor of safety.
Right.
This is a factor of ignorance. And many times, it is many times as much as 50%.
Yeah.
And therefore, they use, because there is a factor of ignorance, they put double the steel than they think the load factor requires.
Right.
Now, I personally feel if you just look into these two aspects, you would probably bring down the steel used by about 20%, and therefore the cost of the building. Is there anyone looking into this?
Yeah, no. When I was studying civil engineering, so this was the joke that all my electrical engineering friends and others would crack, is they would say, you calculate things meticulously until the third decimal, and then you just apply a factor of safety.
Exactly.
Now, of course, the factor of safety is important because the load that you've assumed is obviously an approximation. It could be a slightly higher load, things like that. But unfortunately, what is also happening is that in some sense, we are also assuming that the contractor will have poor construction practices, and to compensate for the poor quality of construction, you are over designing it a little bit. So again, the failure to me is systemic. If the contractor can build as per design, if the design strength of the concrete and so on can be achieved, and if the right amount of cover can be given, etc., there is no need necessarily to give that kind of a factor of safety. So I think, unfortunately, see, we realize this as civil engineers, but given the way given sort of the contracting profession and the way in which you select the L1 contractor and so on, it becomes difficult to I know I'm opening up a can of worms here probably late in the evening, but I think that's an issue. Just a quick point on your earlier one about the earthquake, sir, and I think this is where to me this is really more of a psychological reaction. So we had an earthquake, so next time we've got to strengthen these things, and therefore the designs change so that you're roughly using 2 to 3 times the amount of material for an event that probably may not happen in the next 100 years, because these earthquakes are, once the probability of it happening again is now quite low. So to me, it goes back to you're trying to optimize for one thing, and right now this is a knee-jerk reaction to the earthquake, whereas a more systemic optimization where you say, yes, there is structural stability, but there is also sustainability, and there is also constructability and so many other things. Somehow that systems perspective, I think, is somewhat missing in both in academia as well as to some extent in practice and so on. So
and my other point, Ashwin Saab, and of course, is this, that one of the things for which I think, this project we are doing in Chennai, and I did emphasize, I think, taking the whole matter to the people. And when you take this matter to the people, you're talking about this matter to the system as well. I'm just wondering, and I'm asking a very specific and probably an embarrassing question to Ashwin Saab, that suppose we were to organize a series of workshops with contractors and the builders and small contractors and petty contractors. As a matter of fact, people don't realize that the real real strength happens to be if you deal with the small contractors and the petty contractors and if you want to do this, can people like you come in and help? Because like say, for instance, the lucidity and clarity with which you spoke today was absolutely stunning.
Yeah.
And I know this, I know like say, for instance, not now because I'm very old, I'm 82 years old, but when I was younger and when I used to practice, every time a project start, I used to hold a meeting of the laborers, especially skilled laborers. And I do remember an instance where I held a meeting for a project and explained why do we keep grooves in front of while using, I think a wooden frame and a plaster. Now I explained that the coefficient of the heat, is different of wood and this, and therefore the crack develops. And in order to hide this crack, we do this. You won't believe me, but a carpenter and a mason ran to me. This says we are doing this for 30 years, but we know today why we are doing it.
Yeah. Yeah.
But just imagine the kind of ignorance, the kind of non-scientificness that prevails our systems.
Absolutely.
And I think we've got to be not necessarily talking about global things. We've been talking about the small things all the time.
I fully agree.
And I'm very keen that people like you come and help us do this, Ashwin Saab. Karoge?
Yeah. Sure, sir. So, you're absolutely right. And I think you're right that there's no point talking to the L&Ts and the Shapurjis because those guys are all come from good colleges, this, that, etc. And they are actually not the ones sitting there and pouring the concrete. I think we've got to go down one level. Exactly the kinds of people you're talking about. And there the challenge is you need to be able to talk in the vernacular. We need to be able to talk about, nuts and bolts or, like you say, grooves and joints. And things like this. So it's a Herculean task. See, I will say one more thing. See, I mean, of course, India is a large country. I can do something in Chennai, etc. But I think we somehow, given the cell phone penetration and the way internet rates and bandwidths are so readily available, I think we have to look at the online medium for doing all of this at scale is what I feel. Right, because it's such a large country, so many of these kinds of contractors and masons and helpers. We have to think out of the box. I think.
Absolutely.
Ashwin Saab, I think, but we have deliberately and strategically made a choice.
Yeah.
We want it to happen in Chennai.
Yeah.
And we believe it happens in Chennai, will happen in many other cities.
Yeah.
And therefore, it's much better to. That's what I'm talking about. In this particular case, global is local. And that's why that's a deliberate choice. That now don't worry about what happens to anywhere. Don't worry about what happens in Chennai. Show possibility in one place. We will be able to go a little far.
Yep. Absolutely right. If I can just add one small thing, I'm not a civil engineer or an architect. I come from the other side of the thing. I'm a mechanical engineer. We have slightly different ways of looking at it. Our safety margins are often quantified by the industry practice within itself. So we have experts to tell us or codes to tell us what the safety margins should be. There's less guesswork involved. But I think a very important issue was brought out by Kirti Bhai and by Professor Ashwin here, which is our so-called skilled workers, artisans, they came running up to Kirti Bhai to say, we have been doing it for 30 years. By practice, we know, but we don't know why. This also shows the weakness in our entire technical education system, which works for skilled workers, electricians, plumbers, carpenters, etc. We have segregated skills from education. We think you're a skilled guy, you don't need to have education to tell your skills. You just learn how to do it, that's enough. We emphasize know how and not know why. And I think that whole ecosystem This is not the IITs we are talking about, but it's the ecosystem that builds the artisans and builds the construction workers in the industry. We've not paid attention to that as a country, which we need to do to translate these, what we know by instinct and by passing down of knowledge through generations, but to understand the science of it and to incorporate that into our skilling and education practice. And of course, Kirtibai is absolutely right. We are looking forward to doing this in practical terms, in trying to do this in Chennai. The points that I was talking about on behavioral changes in AC use, for example, these understandings that we have built up, we would love to be able to take it down to building societies, to apartment complexes, etc., to bring about behavioral changes which can then improve lives of people, improve the heat in the city, and also improve the savings of people through energy savings, etc. We are about 5 minutes past 8 o'clock. I think we've got, I see one more comment. Good friend Dinesh Abrol has asked about, would the panelists like to talk about the rebound effect in case of energy efficient buildings? The rich can thwart our efforts. I don't know if Dr. Ashwin would like to tackle this. He can do. Otherwise, I'll respond to it if.
Go ahead,
Dr.
sir.
Ashwin?
I'm not quite. Go ahead. I'm not quite sure I understand what the rebound effect is. Please go ahead.
I think the rebound effect that Dinesh is talking about is there is an understanding that if I can save money by a more energy efficient air conditioner, then my bill comes down, then that gives me the confidence, oh, I've got that much extra now which I can play with, so I'll install another AC in my next room somewhere. So that's the rebound effect that Dinesh is talking about. But I think if we look at this in an integrated way, and if we are conveying the message about energy savings, then I think that has its own message. Nothing, of course, prevents stupidity. Yeah. If people want to be stupid and burn more fuel and use more ACs, there's very little that I can do about it. But I don't think it is because of a rebound effect. In this case, it will be because people have more money. And therefore, they feel if I can use one AC, I will use two. The rich, yes, have this problem. The one bright spot in this is that most information that we have seem to suggest that even if the what we call the rich, the 2 to 5% population, blow up energy in their own excessive ways, the numbers on the other side are sufficient to counterweigh on that. This is my response, at least. Kirtibai, is there anything?
I just wanted to kind
okay. So thank you all very much for attending this, for participating in this webinar. And we will be soon notifying the next two webinars that we have. One is going to be on the supply side of what we are talking about. That's the power generation sector, and what does the scenario look like in Chennai for that. So it's up to me now to thank Professor Ashwin Mahalingam, to thank Mr. Sampath Kumar, and even though he is traveling and therefore he is disconnected now from us, Dr. Dhaka, and of course all our participants who have stayed through the discussions, not just directly, but also on YouTube and other channels. To thank you all very much once again. If Kirtibai has any final comments to make, he may do so.
No, I think not final comments, but I think thank you very much. A very rich conversation, and I'm really grateful for everyone who's here. Last thing that I want to do is this. Ashwin Saab, if you could help me do this. I designed for at IIT Chennai, Madras, this big building, you know, which is supposed to be an interface between industry and college.
The research park. Yeah.
The first building,
Mhm.
and used the entire basement for water storage, you know,
Mhm.
and huge capacity we created in order to kind of, you know, and I thought, you know, that was wasted space, and I think, you know, we do this. So if you ever, and of course, Professor Junjunwala said this is the only good thing you did, Kirti. But I thought, you know, if you could find out it's still being used and if it's still being effective in terms of water conservation and water storage, I'll be very happy.
I'll get back to you on that, sir. I'll find out.
Thank you very
Thank you all very much once again. Thank you.
Thank you, everyone. Thanks for the invitation. Really enjoyed the session. Thank you.
Great.
Sir.
Thank you.
Thank you, everybody.
Bye bye. Good night.
Bye. Good night.
Good night.
Thank you, Chitrakshi, as well, because she's the one person I forget every time to thank. She's doing huge amount of work at the back. So thank you, Mamaji, and thank you. Thank you, of course, Raghu Saab. Thank you.
Thank you all. Bye bye. Good night.
Good night. Thank you.